Okay, today we're talking about light reflection and light transmission, which is what we're going to get when we pass through a filter. This is what happens. This is what happens to light and color when it bounces off an object, and this is how we get color, or how we see color. So right now we have a piece of yellow, a yellow colored thing, a yellow colored paper, and we have an incident ray of light. Okay, here's our incident light coming into, and it's coming in. It's going to hit our object. This object, now this light, this incident light, it's white light, but white light has the whole spectrum, right? It has all of the light in there. What this object does is, in order for the yellow to reflect off, it's sort of addition by subtraction. And that in order to get only the yellow light coming off, all of the other things get absorbed into the yellow. So this thing will absorb the red, orange, green, blue, and violet. It absorbs that light. It does not reflect it. It gets sucked in there. So you have this instant light coming in, and if you have a yellow object, the only way we can tell that it's yellow is when that is the light that shines into your eye here. Okay, is your yellow light. Okay, that's what gets in your eye, and it's the only. So when you look at an object, only the colors that are bouncing off of that object are going to hit your eye. And it works with all of them. So a blue object is going to absorb everything other than blue, and a green object is going to absorb everything other than green, and that's what hits your eye. Now, we have a different situation if we are dealing with a filter. So we're going to... actually, you see it a lot in... this theory is really important in stage lighting. So let's draw a shape here, and we're going to fill it with... Okay, so let's do... so let's do this. Let's draw... Stop. Next page. That's what I want. All right, so we're going to have a stage with a proscenium, and we're going to have a light fixture up here, and this light fixture shines white light coming out of it. Okay, so it's going to send white light out. However, in front, before that white light hits the stage, they pass what's called a filter. And now I want my shape. And I want it to be purple. And I want this to be gray. And we're going to do and the light that passes through the filter, though, is now... it now takes this color. Okay, onto the focus spot on the page. All right? And so you put this filter or light. But what this does, instead of... The weird thing is that this light, in order for this to look, in order for this to be light, it's actually, light is additive rather than subtractive. So all of the light that's hitting the stage is all of the light except this color. Okay, which is kind of weird. So if this looks purple, then the light that is hitting the stage, this absorbs purple. Right, so okay, so this. Okay, it absorbs purple. Okay, and it transmits all of the other colors. So if light is allowed to pass through, okay, if you have something that's transparent but it has a particular color, the light that's allowed to pass through it is all of the other colors, just not the one that it's absorbing. Whereas in the previous version, if it's bouncing off of a solid object, okay, if we're looking at reflected light, then this is absorbing all of the other colors and only reflecting the light that we do see. Okay. Yeah. Okay, and so this over here is called light. This is light transmission. Now, the cool thing is, there's a similar process that happens in your television. In particular, and that's sort of a limitation of what we see with digital projectors and LCD and plasma televisions, is all of the light that they pass off is versions of red, bigger, that, okay, is red, okay, green, and blue, and they're usually arranged like this. Or actually, I think on cell phones they're actually arranged. They're ranged horizontally, so it's more of a they're ranged right next to each other, but they're really small. Okay, each pixel on your phone, so if you have a Retina display or something like that on your LCD phone, each pixel has this trio of colors on it. Okay, and it's a combination of the intensity of these colors and how some combination of the intensity of these three colors will produce any of the light that you see. Now, mind you, these are not the primary colors for pigments. Okay, when you paint, the primary colors are when you paint something, primary colors are red, blue, okay, and yellow. When you're painting something, and so traditionally we know that yellow and blue make green, and red and blue make purple, and you make your color wheel and that sort of thing. That's not the case when it comes to light. Light, it is red and blue make something called magenta. Okay, blue and yellow, and blue and green make yellow, and red and green make orange. Okay. And this takes some getting used to when you're thinking about how you want to make light patterns as opposed to mixing your pigments. Okay. Right. So that is. Oh, okay. Then one other thing. So with light transmission, if you have a black filter, okay, it just doesn't let anything pass through. That black, the color black, is the absence of light. So a black filter just means that you're blocking all of the light. But if you come back over here, we can see that things are black. So if I were to take this shape and make it black instead, okay, then black light is what bounces off of our eye. Well, if this is black, then it's absorbing all of the colors. There is no color bouncing off of a black object. Okay? Some black objects, however, themselves are shiny-ish, and so it reflects all of the light. Okay, but if it's a matte black, that's why you see this trend, which is kind of silly right now. You have cars that are this matte black. They're trying to reduce reflection of light altogether. It's because at night, okay, no light reflects off of it, so it's like they're not even there. Okay, and so they rev their engines because they want to sound cool rather than look cool. Okay, but if you have light hitting your object, and if it absorbs all of your letters, okay, including your yellow, so then you have no color bouncing back, and what you're seeing is the complete absence of light is what the black is. Okay, and if it's white, then you see all of the colors bouncing back. Know what I'm saying? Okay, that is sufficient for you guys to work on your work today. The rest of it, you guys should be, well, not really the rest of it. You guys read and try and figure this out.